everyone. Okay, I'm going to go through these notes. I'm going to try to go a little fast. You can always pause or go back, or even speed this up if I go too slow or if the video is too long for you. Okay, so in class last time we talked about this new idea of this parametric equations, where we have two equations that are coming together with a third variable called that parameter. So we're taking those x, y, two-dimensional coordinates, telling us that when the object is at a given point in the direction of the path. So typically it's going to be time. And so we're going to graph a couple of them today. Okay, so when we're going to graph in example 1, the parametric equations x equals t plus 2 and y equals t squared over the parameter interval from -2 to 2. So in the table, I already put -2 to 2 as my t values, and I'm going to input those t values into each equation. So for x, I'm going to input it into t plus 2, and for y, I'm going to input it into t squared. So go ahead and fill those out. I'm going to do that as well. So it's when I fill out these tables, I might go a little bit fast, because you should be able to do these on your own or just substitute them in on your own. Okay, so once you have those filled in, you are going to graph them as single xy coordinates, but what's going to happen is you're not going to connect them with like a typical line or a typical just connection. You're going to connect them with arrows to show the direction in which they're going. So at the first point, when t equals -2, okay, we have 0, 4. So I'm going to plot the point 0, 4. And for the next second, when t is -1, I plot the point 1, 1. And I'm not going to connect them just individually. I know that when t is -2, I go to the direction. So I'm going to kind of show this arrow that I should be going to 1, 1. Then I go to 2, 0. So another arrow. It's kind of hard to do with that little space. 3, 1. So it's showing the direction, 4, 4, as well as over the time. So yes, this is being connected, but the arrows are showing the direction in which they are going for that time. So that's where we can show that interval for time. So we could actually take away that parameter. So if we want t to go away, to create a new equation in terms of x and y only, what we're going to try and do is take each equation and solve for t. So if I take that x equation, x equals t plus 2, if I solve for t, it's going to be x minus 2 equals t. And if I have the y equation, y equals t squared, okay, I can take that t and substitute it in for t. So I'm going to take this, since it's t equals, and I'm going to substitute it in for t so that I'm eliminating t and replacing it with an x term. So y equals t is now x minus 2 quantity squared. So it creates this new equation in terms of x and y only. And the domain for this equation, I know it doesn't say it, but we do like to say the domain for this. So using the graph or just using the x values in the table that you found, 0 is less than or equal to x, which is less than or equal to 4. So for this equation, it appears from 0 to 4 on the x, when y equals x minus 2 quantity squared. Okay, so I would like for you to pause this video and try this next one on your own. Excuse me. And when you're done, you can always speed up my video so that you don't have to see me doing the work, but I'm not going to talk through this. You'll just kind of see my writing appear as I go. Okay, hopefully you were able to complete that one on your own, just using those x and y parametric equations, graphing them on the interval from -4 to 1 for t. When you create that equivalent equation in terms of x and y, same idea, I solved for t in the x and I substituted that in for t in the y equation to eliminate the parameter and only worry about x and y, and I simplified it and identified the domain of that new equation, y equals 2x plus 6. Okay, we're going to do the same thing on the back, but we're now going to, instead of doing a linear or a quadratic equation for x and y, we actually are going to start using some trig functions. So the table just takes a little bit longer to fill out to determine, but we still take the same approach when we create our table and graph those points. So if my x is now 5 times sine of t and y is 5 times cosine of t, we're going to do the intervals from 0 to 2 pi. I already created those intervals, and just like our unit circle, we use those nice clean points. Like when we were graphing sine and cosine, we had the 0, the pi over 2, the pi, the 3 pi over 2, and 2 pi for the whole way around that circle. And we can identify if we were to substitute 0 in for t, so sine of 0 times 5 is 0, and then cosine of 0 is 1, and 1 times 5 is 5, so I'm just using those unit circle points. Sine of pi over 2 is 1 times 5 is 5. Cosine of pi over 2 is 0, so 0 times 5. Pi, sine of pi is 0 times 5, 0. Cosine at pi is -1. 5 times -1 is -5. So on and so forth. So I fill out the rest of my table here, just knowing those points of 1, 0, 0, 1, -1, 0, and 0, -1. So I'm just using those points to find those sine and cosine values and multiplying them by 5. So once again, I'm going to graph these points. And you're going to see that they kind of go back and forth. So notice how I'm going to be connecting them. So I start at 0, 5. Then I go to 5, 0. Okay, I'm not going to draw a straight line because I know that cosine and sine are curves. So this will be kind of a curved, but when I go from 0 to -5, you're going to start to see the shape appear of this. So you can actually see it kind of creates these curves, directions, and it's creating this circle with a radius of 5. Okay. And so the circle that is created from these parametric equations can be written in a circle form equation. And if I want to get that equation, so I want t to go away, I need to figure out, well, how am I going to get t to go away? Okay. I also want to think about, this looks like a circle. So if you recall circle equations, x squared plus y squared equals r squared. Okay. If I want to get to that circle, you can kind of assume, like figure out what the equation is just by looking at the graph. That since we're centered at the origin and our radius is 5, you should hopefully know what the equation is. But let's see how this appears. So I know that my x is 5 times sine t. I don't like the way I wrote that. I'm going to rewrite that. And cosine is 5, y is 5 times cosine of t. Okay. Now I need to get rid of that t, but since those are inside arguments, I need those arguments and the sine and cosine to completely go away. If I wanted to know that my circle equation is going to be x squared and y squared, I know that x squared is the same thing as 5 times sine t squared. So I'm going to square this to get the x squared. And then the y squared, if I was going to think about this as y squared, if I square the 5 times cosine t, if I square that, that's the y squared. If I add those together, okay, how does that help me? Okay, I know this is coming, these mean the same thing, okay. 5 times sine t squared plus 5 times cosine t squared equals x squared plus y squared. Those mean the same thing. So if I actually figured out what those are, this is 25 times sine squared t, and then plus 25 cosine squared t. Okay, this is the same thing as x squared plus y squared still. Okay, how does that help me? I can factor out that 25 and give me sine squared t plus cosine squared t. That's still equal to x squared plus y squared. And then why does that sine squared t plus cosine squared t just go away? It's going to go away because that is our Pythagorean identity. So that means we have here 25 times 1 equals x squared plus y squared. So 25 is our r squared. So this is kind of showing that, yes, our radius is 5. This is a circle equation, and it's centered at the origin, so that's where this is coming from. Okay, this was kind of, I had to push you to get there. It would have been difficult for you to kind of figure out on your own. But the whole goal here was to get rid of the t, and so in order to get rid of the t, I had to get rid of the sine and cosine. And so the way I was able to get rid of the sine and cosine is by squaring both of them so that I could use the Pythagorean identity. Okay, so that's going to be the same idea in number 4. But we are going to have to do a little bit different of a case because it won't be a circle. So go ahead and fill out the table on your own. So pause this video and try and fill out the table and graph the points. And then try and figure out the last part on your own. But if you need to, you can come back to the video for me to explain it to you. So I'm not going to talk through where these points are coming from because I'm just substituting those values in using the unit circle knowledge of those points and evaluating the x and y's. If you are noticing this, this is actually going in the opposite direction because it's going in order of the time. Okay, so hopefully you're able to graph that all on your own. If you notice here, it does look like a circle, but it's not a perfect circle. So this is actually a new type of graph that we don't do in this class, but this is an ellipse. Okay, an ellipse is like an oval. So you do have a radius horizontally and a radius vertically that actually will appear in our equation, but we haven't really done ellipse equations yet. But I still want to try and get rid of that parameter t value in our two equations. So I'm going to rewrite the equations down below. So x equals -1 plus 3 cosine t. Y equals 2 plus 4 sine t. Okay. On this one, I'm going to take a different approach. I don't want to get to the x squared, y squared yet. Because if I squared that, then I'm going to have a binomial that I need to square. If I squared x, I'd have to figure out what -1 plus 3 cosine t, the whole quantity squared, would be. So instead, what I'm going to try and do is actually get the cosine and sine by itself. So when I square it, it's going to be already a little bit easier for me to use. So I'm just going to rearrange these and get cosine by itself. So I have to add the 1 and 3 cosine t divided by 3. So I get x plus 1 divided by 3. Okay. Then I have to subtract the 2. 4 sine t divided by the 4. So I get y minus 2 divided by the 4 equals the sine. Okay. The reason I can do that is because now I can think about it as in terms of that squaring. If I want I still need to get sine and cosine to get out of my equation, but in order to square those, I need, for my Pythagorean identity, I don't want x squared plus y squared, but if I do, I know the Pythagorean identity is sine squared plus cosine squared. Okay, the reason I could do that is now I can take sine and I can square it. So sine is y minus 2, all divided by 4, I can square that. And then add that to cosine squared, which is x plus 1, all divided by 3, square that. And the left side, cosine squared plus sine squared, t can turn into 1. So 1 equals, if I wanted to just simplify this a little bit, I could leave this as y minus 2 squared and square the denominator to be 16. Here, x plus 1 squared over 9, because I'm squaring both of those. I did forget to write the domain up above, but this domain for x is 2 to 2. Excuse me, 2 to, oh gosh, 2 to 2, that's so silly of me. I was looking at the top to bottom number. Domain would be negative 4 to 2. Here. And up above, I did forget to do that, from negative 5 to 5 here. Okay, so each one of these took kind of a different approach, but the whole goal was still the same, is how do I eliminate the t? So you have to think of strategies for eliminating the t, and in both cases, it was to square them so that I could use that Pythagorean identity. In example 3, I was able to just square them right away, because I didn't have to do any multiplying of binomials, but in B, I had to rearrange them, so when I square them, it wouldn't be having to do anything extra to get that sine squared plus cosine squared into the Pythagorean identity. Okay, so hopefully this made some sense. We're going to be talking about the calculator more next time, on how you can actually show this on the calculator and check your work, but I don't want to do that in this video. Hopefully this was okay for you to follow along, and we'll talk more about it next time. Thanks.